Hello students, we are solving a question which is mostly from electromagnetic induction. It is a match the following question from 24th January shift 1 of JEE Mains 2026. On the list 1 side we have 4 physical quantities whose dimensions we should match with list 2. So let's begin. So the first quantity is magnetic induction. Magnetic induction generally refers to magnetic field. So by Lorentz force formula we know QVB is equal to the value of force. That means magnetic field is equal to F by QV. So I've written dimension of force. Dimension of charge is current into time. So ampere into time power 1. And dimensions of velocity is L power 1, T power minus 1. If you calculate this, it will come out to be M power 1, L power 0, A power minus 1, T power minus 2, which matches with the third dimensions in the list 2, this dimension. Similarly, magnetic flux is defined as magnetic field into area. Since we have just calculated the dimension of magnetic field, we'll substitute that here. Dimensions of area is L square. So the dimension of magnetic flux will be M power 1, L power 2, A power minus 1, T power minus 2, which matches with the fourth entry in list 2. The third quantity, which is the C quantity in list 1, is magnetic permeability. For this I will use the magnetic field due to an infinite current carrying conductor. B is equal to mu naught I by 2 pi d. From this I can get the dimension of mu naught as the dimension of 2 pi dB divided by I. Now remember that 2 pi is a mathematical constant. Since 2 pi is a mathematical constant, it has no dimension. D has dimension of L power 1. Magnetic field's dimension I just found in the first case, so I am just substituting that here. M power 1, L power 0, A power minus 1, T power minus 2, right? And in the denominator you have the dimensions of current, which is A power 1, and this will lead you to M power 1, L power 1, A power minus 2, T power minus 2. So the C in list 1 matches with the first entry in list 2. Finally you have self-inductance. So here we will use the definition of magnetic flux. Magnetic flux is self-inductance into current. So self-inductance will be dimensions of magnetic flux divided by dimension of current. Dimension of magnetic flux we have already got in the B section of the list 1. So we will substitute the magnetic flux dimension here and current dimension, and you will get the dimensions of self-inductance as M power 1, L power 2, T power minus 2, A power minus 2. In these type of questions, it is always better to think of formulas of these type, of in which you already have some known quantities whose dimensions you already know, so that you can find the dimension of unknown quantity. Many times students try to brute force in calculating dimension by doing dimension analysis. They will raise everything to the power of A, B, C and try to solve the question. I feel that is not an efficient method. The more efficient method for dimensions is to find out formulas of the unknown quantity in terms of known quantity and use that for obtaining the dimensions. So according to us, option 3 will be the correct answer.